Welcome to PowerPods, our Living Legends series. This collection of podcast episodes is dedicated to company and industry legends. History relived through their stories.
Okay, so welcome back to our Living Legends series here at PowerPods. Today here with me, I have Allen Bernstorf. He is a retired principal engineer for the Insulators business unit here at Hubbell Power Systems. He has been with the company for 40 plus years. Welcome, Allen. Thank you so much for joining us today.
Thank you for inviting me, Joanna.
So, Allen, tell us a little bit about your background and how you started your career with Hubbell.
I always like to refer to myself as summer help that never left. I actually started with the company on June 6th, 1977. I was a freshly graduated physicist, and my plan at the time was to return in the fall to pursue a master's degree. So they really did hire me on as summer help. Ohio Brass at that point had just introduced a new product line, the Highlight Insulator, and they were looking for help over the summer in performing testing of that particular product line. So I came in and started running tests for them. But with my physics training, we're always taught that no test is ever complete until the report's been issued. So as I did these tests, I would issue a report for each test and submit it to my boss at the time. Now, after about 6 weeks of this, the chief engineer sent back a note and called me into his office. This was sort of like being called into the principal's office, if you will. No one got called in to see the chief engineer unless they were in trouble. So I went up to his office with a great deal of fear and trepidation. And when I walked in the middle of his desk, he has this stack of reports that I've written sitting there. At this point, I'm thinking, I'm in serious trouble here. And he just turned and looked at me and said, "Did you write these?" And I sheepishly admitted that, yes, I did. And he looked at me and said, "How'd you like a full-time job?" I stuck around after that for 40 years and retired on June 6th of 2017, exactly 40 years from the date I started.
Wow, that is a great story. So how have you seen the industry change over the years? I mean, you mentioned obviously you retired in 2017, so you have been with the company for 40 plus years. How have you seen changes in the industry?
Probably the biggest change I've noticed in the industry is what we would term power quality. People look at things today, and things that in 1977 they would just accept, short power outages, minor issues with insulators that might cause disruptions to power, are no longer acceptable. With all the advent of microprocessors and things, even a minor blip in power can be disastrous for some people. So today, insulators have to be much more reliable than they were in 1977, as well as all the other components that go into the power grid. They're just not willing to accept that minor outage. And the end result is they expect insulators and other utility products to last for a much longer time than they did back then.
So what are one of your best memories being here at Hubbell?
The best memories? That's a very good question. When I first started, I spent a couple of years here designing relatively small items, working on projects, and then they turned me loose in 1979 on a porcelain line and station post plant in Newell, West Virginia. Now, this was a very old plant. It had been around for a long time. And a lot of the porcelain designs they made back then were essentially done by trial and error. And by that, I mean, when you designed a product, you knew what the parameters were that you wanted. You knew what the length had to be. You knew what the diameter had to be. You had a pretty good idea how many weather sheds you needed. But in a lot of cases, they would sit and try and draw these things, and they would put them together, and the lines wouldn't quite close. So, you'd try a design, and then you'd try something else until you could get the whole thing to work. When you came up with a workable design, you might look at the leakage distances and the strike distances on the design, and then you'd sit back and say, well, that doesn't meet the criteria. So you'd start over again until you finally got something that would work and fit the initial design criteria. Now, on the other side of it, in the manufacturing process, they would build these insulators. We thought we had a pretty good handle on strength, but they would test them. Sometimes they'd run into minor issues, and we'd keep trying things and working until we got to a point where the designs met the criteria, again, with which we started. Let's put it that way. In doing that, I realized that the entire porcelain design could be modeled geometrically. And even though this was 1979, PCs hadn't even been introduced yet, what I did was we had access to a timeshare computer service. And I had been trained in college to program in Fortran 4. So what I did was I modeled porcelain line and station posts geometrically using a Fortran 4 program. And in the process of doing that, I actually went in and calculated the stresses that would be applied to the design over every single inch of the design in the process. Just by doing this design. What that did for us was it shaved our design times down from, say, 4 to 6 hours down to minutes. And it gave us the ability to look at products within the plant and analyze where the high stress points were likely to be, where the failures were likely to occur, and to adjust those in advance of actually building product. The end result of that was greatly reduced design times and also much better QA data. The result of that was lower losses in the plant, better productivity. It was a great learning experience because it taught me how being proactive in your design and in your manufacturing philosophies can really improve your overall processes.
That is awesome. And is that one of your first major design assignments that you worked here at Hubbell for?
That was the first major design, yes, major design assignment. It was responsibility for that particular manufacturing plant.
So what would be some other of the designs that you were assigned?
Well, at the same time I was doing that, I was also designing highlight insulators, working on those. So really I had dual roles back then. I worked on the polymer side. I also worked on the porcelain side. That gave you a lot of experience overall in how insulators worked and in the different types of designs, the different types of materials that you could use to build insulators.
That's awesome. So during your career here at Hubbell, what do you consider to be your best work?
The best work that I ever did was probably the Quadracil product line. And I can't take all the credit for that because a gentleman named Bas van Bassel and I worked on that together for over 2 years. And the reason it took so long was it had a number of innovative features that were built into the design. We had been building at this point polymer insulators for on the order of 30 years. And we had worked with those. We had seen all the pitfalls in the designs, all the minor things that we could correct and make better designs. We'd had a great deal of experience looking at these and determining if I were going to build from the ground up a new design, how would I make it better? And we tried to include all of those things in the Quadracil design. For example, it was our first true transmission class design that used silicone rubber housings. And these housings were direct molded to the fiberglass rod. We had never done that in a transmission class insulator. We accomplished that by molding in small segments, and as a group, we developed a process that we called jump molding, where you mold a section, you move the part down, you mold the next section over it. This was possible because silicone rubber has the unique property that even though it's been molded and cross-linked, you can still cross-link new silicone rubber to it. So we were able to overlay different sections. When we got to the end fittings, we decided that we were going to integrate the Corona shielding ring into the end fitting. This stemmed from a lot of history with designs that if they were involved in a power arc, if you had a separable Corona shielding ring, it would be damaged and might have to be replaced. It might also result in replacing the entire insulator. So we integrated it into the fitting itself to make a much more robust design that was much more resilient when it experienced a power arc. Now, because we did that, all our older designs had rolled crimps that went over the end fitting. Well, now we had this Corona shielding ring that was built into the end fitting, so we couldn't do that anymore. So then we had to turn around and find a new way to crimp end fittings on. And we developed it using fin power crimpers and using what we termed a circumferential radial crimp design. Since we were building this CSR into the end fitting, we also decided that we were going to integrate a 4-seal design at the point in which the rubber entered the end fitting. Now, that point's sometimes called the triple point of the insulator because actually it's a location where the metal of the end fitting meets the rubber of the housing and also meets the fiberglass rod. And we decided that we were going to truly protect that point because that's the weak point in any insulator design. So we built these 4 seals into the end fitting, and we named it the Quadrasil Insulator. Now, the interesting thing to us, and the part that we are most proud of with regard to that design, is because we used our past experience and we developed this thing knowing everything that we had learned over all those years of building insulators. We introduced this design in 2007, and to date, we have yet to see the first triple point failure of the insulator, or for that matter, any interface failure on these insulators. It's been an incredibly robust design for us.
That is so awesome. So what advice would you give to someone that is just entering this industry?
If I were looking at it today, knowing what I know and knowing what I've been through, the one thing I learned along the way was that you should always ask why. Don't just design things to design things. If you're looking at something that already exists and you're being asked to redesign it to do something else, question every feature of the design and try and find out why that particular design was developed the way it was. That's going to enable you to go forward and have a better understanding of exactly what it is you're trying to do and in what ways you can make improvements to that design, whether it be through material reductions or beefing up of certain areas because of stress concentration factors that might exist there, or even if it's just, as in the case of the Quadrasil, designing something that's going to be more resilient to power arcs in the field. These are the kind of things that are really going to make you better at your job.
That is a great advice, and I think that applies not only to this industry, but just in the workforce in general. I want to thank you, Allen, for being here at the Living Legends series. I really appreciate all the conversations and all the points that you touch and all the advice that you're able to give to everyone that wants to be part of the industry. I really appreciate it, and I hope that you have a great day today.
Thank you very much.